I thought installing T-tracks and a spoilboard would be simple, but it wasn't as easy as I thought, and it took a whole lot longer than I expected. I watched several videos of others installing T-track and spoilboards, took the best ideas, and formulated my own plan. I calculated where one of the T-tracks, then opened my Vectrex software and created CRV and TAP files. I'll give you a brief look at that soon. I started at the X, Y, 0 points for the machine, which I determined by using the pendant to move the machine to the farthest it could reach on the X and Y axes in the left front corner. Then I added a 90-degree V-bit to the collet and lowered it just enough to leave a slight impression on the plywood. I did the same thing on the remaining 3 corners until I had the entire working area of the machine mapped out. I decided to make the MDF sections each 5 inches wide with a 2-inch wide strip on the left and a 1.5-inch wide strip on the right. So let me give a quick summary of how I made the file I created in VCarve Pro to cut the grooves for the T-tracks. I opened a new file and entered the dimensions of the spoilboard and T-track. The X is 50.5 inches, the Y is 49.5 inches, and I used 0.75 inches for the thickness. That's the depth of the top plywood layer. Essentially, what I wanted to do was cut a long rectangle out of the plywood to inlay each T-track. So I went to the Create Vectors section and selected the rectangle shape. The anchor point for the first groove starts 2 inches from the left side of the X-axis and exactly on the Y-axis. So I set the X anchor point to 2.0 and the Y to 0.0. I want square corners, and for the size I want X to be 3/4 of an inch or 0.75 inches. We need to think in decimals for CNC. I need the Y to be 48.5 inches to allow room for the T-track and an extra 1/2 inch for an entry point for the clamps. I made those entries, circled, create, and then close. Now I was ready to draw in the next rectangle. I had double-checked all the numbers and written them down so I could enter them confidently. The MDF sections will each be 5 inches wide, so if the first groove started at X 2.0, the next will start at X 7.5. That's the starting point of 2.0 plus 0.75 for the T-track plus 5 inches for the MDF. The Y dimension doesn't change. I entered the X starting point for each subsequent groove from my worksheet, and then I was ready to move to the Toolpath side of the Vectrex software. I selected all the grooves and set them up as a pocket since the cut would only go partially into the wood. I set the cut depth to 0.37 inches, the height of the T-track, and selected a 1/4 inch end mill as the bit I would use. The software had already decided on 4 passes. I know that was a good choice, so I left it as is. Rather than just letting the bit drill straight down and then begin cutting, I set it for a 1.5 inch ramp entry. This is easier in the router bit. I named the file T-track pockets 0.25 end mill and clicked the calculate button. This file naming method is a tip I picked up along the way. The first part of the name describes what the cut will do, and the second part tells you which bit was used. This will save having to look up this information if you make the item again. That's not likely here, but for many projects, it could prove a big time saver. As soon as you click the Calculate button, Vectrex switches to 3D view, and you can see what the machine will do when you run the program. I can see that this was set up properly. We will have 9 3/4 inch wide grooves, spaced 5 inches apart, starting at the bottom of the cutting area and proceeding upward 48.5 inches. I closed that section, moved to the icon indicating where to save the file, saved it to the post processor for a Next Wave CNC HD544 as a .tap file in inches, and saved it to a USB drive so I can connect it to the Shark's pendant. I saved the CRV file to the location where I keep these files, and I was ready for the next step. With the file created, I'm ready to start cutting the grooves for the T-track. The first step is to install my 1/4 inch downcut bit. Then I plugged the USB into the pendant, located the file, and loaded it into the machine. I pressed the spot for the correct operation on the screen, and the system displayed a picture of what the software showed the machine would do. There were 9 vertical lines on the screen, pretty boring, right? Indicating the 9 grooves that were going to be cut. Since that looked correct, I was ready to proceed to the next step. I already had the spindle at the XY 0 point, and now I needed to set the Z0, which is at the top of the plywood base. There's a connector at the end of a wire with a magnet around it that you attach to the collet, and then you select the touch plate option on the pendant screen, then 0 to Z, and you pick up the touch plate and gently hold it against the bottom of the router bit. You touch the connected button on the pendant, move the touch plate down to the surface, and the Z-axis slowly moves down until the bit kisses the touch plate. The motor then moves the collet a safe distance above the touch plate. I moved the touch plate out of the way, placed it in the holder, which I've installed on the front of the plywood. The spindle is fairly quiet compared to the screaming of a router, but the bit cutting wood generates enough noise that you need to wear hearing protection while the CNC is cutting. I programmed the spindle to ramp into the cut because that's easier on the router bit. Once that part of the operation was completed, the gantry moved the bit straight back to the rear of the cut. Then it moved over and made a cut in the opposite direction, coming back toward the front. When it reached the front, it stepped slightly to one side and resumed cutting toward the rear. The software determines the most efficient pathway to accomplish the cuts. After it's made a cut across the full width of the groove, the machine lowers the router bit and makes the same set of cuts, just deeper. It will take 4 passes to achieve the width at each depth, for a total of 16 passes to complete each groove. This is going to take a while. I told you this was going to take some time. I ran the CNC for about 2 hours, and during that time I cut the first 5 of the 9 grooves. It was getting to be time to go, so I stopped the machine before it started cutting the next groove. One of the strengths of a CNC machine is repeatability. I programmed these cuts from the XY 0 points, so I returned the gantry there before I shut the machine off. I'll start with the machine at the XY 0, and all I have to do is set the Z0 again. By the way, that little pile of sawdust is what was generated by the cuts yesterday. In one way, it was fortunate that I had to stop. I test fitted a T-track to the first set of grooves and found they needed to be a tiny amount wider and deeper. I set the width for 0.75 inches. The exact width of the T-track is measured with a caliper. But that was too tight, so I elected to redo them to a width of 0.77 inches and later found that to be a perfect width. Likewise, I'd set the depth at 0.37 inches, the exact thickness of the track. So I reset the depth to 0.39 inches. It only took a few minutes to update the file. I uploaded it to the USB stick, and I used that to update the pendant. The grooves are all cut, and with the width and depth changes, the T-track is a snug fit, exactly what I wanted. The next step is to install the T-tracks by sliding them into the grooves, then screwing them into place with 1-inch wood screws. Drywall screws are not appropriate for this application. They are flathead screws, and the heads fit perfectly into the tapered holes in the track. I made the grooves a 1/2 inch longer than the T-track, and I'll push them all the way to the back of the groove. That will leave space at the front of the tracks, giving me room to insert the bolt heads that will keep the clamps in place. A bag of 3/4 screws came with the T-tracks, but I wanted them a little more secure, so I bought a bag of 1-inch screws at the hardware store. The Ace store is not far from mine, so it's easy to stop by anytime I need something I sell. As a bonus, they offer a 10% veterans discount on any regular priced item. This is one of those times to be thankful for a battery-powered drill driver. I'm going to use most of the 100 screws in this bag by the time I'm done securing all 9 T-tracks. It's time to install the Spoilboard. I cut 8 5-inch strips of MDF from 2 24 by 48-inch MDF panels. From what was left, I cut a 2-inch strip for the left side and a 1.5-inch strip for the right side. There were only 2 small strips left over. These strips provide coverage for the full working area of the HD 544. It looks like an aircraft carrier deck compared to the postage stamp of my old machine. I cut the MDF at home on my table saw, then drilled and countersunk screw holes with my drill press. I wanted the depths to be consistent, so all the bolt tops would be the same distance below the top of the MDF. This will allow me to resurface these tops several times before I have to replace the MDF. I drilled 2 parallel rows of holes, each 1 inch from the edge. I made 7 sets of holes, so each strip can hold 14 bolts in place. That's probably more than I'll need, but I'd rather have too many holes than not enough. I don't want to have to drill and countersink with a handheld drill. I was pleased to find the MDF strips fit perfectly. That meant my math was correct, the Feelin groovy file I designed for the CNC was going to be perfect, and I had accurately set my fence and cut all the strips on the table saw. I was on a roll. By the way, the Paul Simon song Feelin Groovy, the title's actually the 59th Street Bridge song, has been running through my head on and off ever since I started cutting the grooves. I thought about using it for background music for the last few minutes, but I couldn't find a free version. If I used the original music, this video would likely be taken down and a copyright strike issued against me. It wasn't worth the risk, and it was also likely that not everyone would get the little joke anyway. I used the holes in the MDF as a guide for where to drill the holes in the plywood that would accept the threaded inserts into which the hold-down bolts would be screwed. The holes were 1/4 inch to accept the bolts, but the threaded inserts require 5/16 inch holes. I couldn't drill that size without ruining the ability of the bolt to have material to hold onto, so I drilled 1/4 inch holes using MDF strips as a guide, and then I moved the MDF strip out of the way, switched to 5/16 drill bit, and used that to make the holes for the threaded inserts. Once the 5/16 holes were drilled, I used an Allen wrench, which was supplied as part of the threaded insert and bolt kit, to drive the threaded inserts down until they were flush with or slightly below the surface. It may be possible to insert these with a driver, but I didn't want to take a chance on a process I'd never done before. It was a slow process, but the end was in sight, and I just kept driving one insert after another. I didn't use all the holes, as it seemed some at each end and a pair in the middle would be plenty strong. When the inserts were in place, I added a bolt and tightened it down with another Allen wrench supplied with the insert bolt kit. Again, it was a slow process, and I was looking at a long line of these to put in place, but I was getting excited about finishing this up so I could actually start making things. Now that the foundation is in place, the real fun begins. So subscribe and follow along as I start turning this setup into finished products I can actually sell.